Here we are. We're going to use a remainder theorem today to find parts of a polynomial if we know that a linear binomial is a factor indeed. So remember that the remainder theorem says if we take a function and we divide it by a linear term, x minus b, it is the same as if we were to plug the opposite, that minus b, if we were to plug it in as its opposite into the original function, which is right there. We're going to apply that. So it says, given f of x equals x cubed plus kx squared minus 1x plus 30, find the value of k such that x plus 2 is a factor. Now notice this, k is right here in the original equation, and the factor is x plus 2. Well, the remainder theorem just simply says if it's a factor, okay, so x plus 2, we need to check when x is equal to -2. The other thing we also know is if it's a factor, the remainder is 0. Okay, so let's write that down. Remainder is 0. Okay, and the remainder is if we plug in the opposite into the original equation. So let's do that. We have taken our opposite of x plus 2, which is now x equals -2, and we're going to plug that into our original equation. So I'm going to bring that down here, and I'm going to write -2 cubed plus k, then -2 squared minus 1 times -2 plus 30. And because it is a factor, I'm going to set the remainder to 0. At this point, it's just solving algebraically. I know -2 cubed is -8 plus -2 squared is 4k, and then -1 times -2 is going to be +2 plus 30 equals to 0. I bring all this information. I need to find what is -8 plus 2 plus 30. So we get -6 plus 30, which is 24. So I write 4k plus 24 equals to 0. We do some basic solving. We just subtract the 24 over. 4k comes out, and then we divide by 4. And k is equal to -6. So now let's go ahead and check that on Desmos, because obviously that's going to be the smartest thing for us to do. So I need to put a -6 right here. So and we want the factor to be the remainder to be 0. So we come over to Desmos. Let's go ahead and plug this in. And you can tell right here, I've plugged it in, x cubed minus 6x squared minus 1x plus 30. If x plus 2 is has a remainder of 0, it is a factor. So x plus 2 is a factor if the remainder is 0. Okay, so there's ways we can do this. Just checking on the other videos, we can say, well, what is f of 2? Okay, well, f of -2 is 0. Okay, and then I can also look at the x-axis, and I can click on x-intercept. So x plus 2 is a factor because at -2, the value is in fact 0. So we've checked our work there. We can see that works, and that tells us that k has to equal -6 in order for this polynomial and that division to work as x plus 2 being a factor.